I'm a game changer. I'm a risk taker.
Hello everyone, this is my presentation for CoSpace Rescue Under-19. About my team, I'm the only member and my name is 𝗲𝗲𝙑𝙀𝙀 and I am from Indonesia. I haven't participated in any robotic competitions. For Rescue Under-19, the main objective is to collect 6 objects, deposit when you have 6 objects, avoid the trap so that we cannot lose our objects and to avoid crash the wall, and then avoid the edges of the map to save from 10-second penalty. So, what is the problem that I have investigated? First, how to make the robot travel to any positions, more effective movement to collect objects and deposit. Second, how to make the robot avoid the obstacles. Now, I will give you the main method that I have investigated. The first one is, to achieve the goal of collect and deposit objects quickly, I need to make a point-to-point targeting. For example, first point, in coordinate x, 100 to 110, the robot will turn to 0 degree. And in point 2, in coordinate y, 235 to 245, the robot will turn right or turn to 270 degree. Now, let's talk about obstacle avoidance. I think there are 3 obstacles in Rescue Under-19. The first one is edge of the map, because in Rescue Under-19, there is no wall in edge of the map. So we can make border use coordinate x and y. We can make x minimum for left edge, x maximum for right edge, y minimum for down, and y maximum for up edge. For avoid the traps, we use RGB sensor to detect yellow and then reserve answer. And then to avoid crash the wall, we use ultrasonic sensor. How is the result? For travel any position, the robot can move as planned, although sometimes the robot moves randomly when the target didn't load, and collect object and deposit more efficient. For obstacle avoidance, the robot can avoid obstacle well. So the conclusion is, first, the current algorithm can control the robot complete the task efficiently. The result of path planning is not perfect, but it can be improved. The challenge is analysis. The mission is gain the highest score from collect and deposit objects. The challenges can be broken down into 3 mini tasks. Task 1 is route planning. We use point-to-point targeting. Task 2 is collect and collection strategy. Task 3 is obstacle avoidance. The overall missions can be solved when the mini task complete. Let's talk about AI algorithm. 1. Square targeting. 2. Color sorting function. 3. Specific trap avoidance. And 4. Specific wall avoidance. The tools and resources. We use RCAP CoSpace Rescue 2021 platform and virtual robotic using artificial intelligence so that the robot can move depending on the orders. The advantage of using above tools and resources is, first, we doesn't need a real area, and second, we can use it everywhere and every time. Implementation. Task 1, route planning. In point 1, the robot will turn to 0 degree, and in point 2, the robot will turn to 270 degree, and in point 3, the robot will turn to 180 degree. In point 4, when the robot fully loads, the robot will go to point 5, but when the robot loads object less than 6, the robot will throw to point 9. Same with point 10. When the robot fully loads, the robot will go to point 11, but when load object less than 6, the robot will throw to point 2. This is my video demonstration for point 4. The robot running to point 2. and then point 3 turn to 180 degree. In point 4, because load object is less than 6, the robot will through to point 9 and turn to 90 degree. And then in point 5, the robot still load object less than 6, so the robot will turn to 0 degree and through to point 2. Robot running to point 2 and point 3. In point 4, the robot have fully loaded, so the robot will go to point 5, 6 and go to deposit area. And this is video demonstration for point 10. Point 2, the robot turn to 270 degree. Point 3 to 180 degree. In point 4, the robot have not fully loaded, so the robot through to point 9. The robot have fully loaded, so in point 10, the robot will go to point 11 and then 12 and then go to deposit area. Implementation task 2, collection strategy. For 5 minutes early, the robot will collect 𝗈𝙤𝙨𝙑 sets and then superplus object that spawn after that. And what minutes left, the robot will collect random colors that are available. Task 3, obstacle avoidance. To avoid the living field, we make border with X and Y coordinates so that the robot can reserve and turn if running out of the map. For the traps, I think there are 2 options to avoid the traps. First, make a border in a trap area, and we use coordinate sensor to avoid that. But the problem when we use position sensor, if there is a lost position in trap area, we cannot detect X and Y coordinate. So for anticipating, we use RGB sensors to detect yellow color and then avoid that. For avoid the wall, we can divide it to 2 areas. If in area X more than 135, the robot will turn left when there is a wall. If in area X less than 135, the robot will turn right when there is a wall. This is my flowchart and show the code. Step 1, begin. Step 2, move forward. Step 3, read sensor. If there is an object, the robot will pick up. If there is a trap, the robot will avoid that. If there is a deposit area and the robot is fully loaded, it will deposit. If there is an obstacle, the robot will reserve and turn. 𝗘𝗱𝗃𝗃. Sometimes the robot moves randomly because the robot did not reach the planned target. So for anticipating failure, the robot still can use ultrasonic sensor and position sensor to get back on target. Second, the robot moving out of the map because the border is to edge of the map. So the border have to distance from the edge. It makes the robot can reserve and turn proportionally. Third, avoid the trap because this is lost position at the traps area. So the solution is use RGB color sensor to detect yellow color and then avoid that. The conclusion and further work. First, the robot can complete the task efficiently and randomize movement in a special area to maximize object collection and get more points. I will try how to make the robot get the super object and how to make it travel to any X and Y coordinate with effective movement. Learning experience. I learned how to make an algorithm and step to the robot on my way. I gain acknowledgement and experience in how to program a robot. And finally, I want to share to everyone, never give up and keep trying to get the best plans and maximum result. This is all for me. Thanks for your attention. Stay safe and have a good day.